Hi everyone and welcome to your first flip lesson while we are out. My plan of attack right now is to pause on what we were doing in class prior to being out of school. We will start reviewing the units that we learned this year, and my hopes is that when we go back to school, we will finish up that unit and hopefully get our statistics unit in before the end of the school year. Now, what I would like you to do is I hope at this point you have watched the tutorial on how to use Desmos. Desmos is an online calculator that you can use if you were unable to pick up a calculator prior to the school closing. So tonight it is Monday night. Calculators are available for pickup tomorrow, Tuesday, from 12 to 6. You can just go right to the office. If you are unable to pick up a calculator, that is okay too. You can use Desmos, which again is the online calculator, and I posted the tutorial on Google Classroom that I ask you to watch, and that is something you can use. All right, so you are now going to watch this Unit 1 review, and there are 10 questions on problematic that I want you to do when we're done. When you are finished completing the problems, you will submit it, but I also ask that you take pictures of your work and submit those as well. Again, not every question needs work, but most of them do, so you can submit it either with the link for the problematic questions, or I posted a separate one because I wasn't sure if the link with the actual questions would let you submit work with it. Okay, so all you have to do is just take pictures with your phone or your computer and just attach them to the link so I can see your work. And I will post an answer key sometime soon after we all have done the problems. All right, let's start with going over some properties. Now, we learned several properties this school year, but the three big ones that I need you to know are the distributive property, the commutative property, and the associative property. Associative property. So the first property we have here is our distributive property. And if you remember, the distributive property means that you take the number outside the parentheses and multiply it to everything inside the parentheses. So 9 times x is 9x, 9 times 8 is 72. All right, and that's when you distribute. Our next property is our commutative property. And if you remember, the little trick I taught you for commutative is that it starts with CO. So things change order with the commutative property. If you notice here, we have x, 9, 2x, and our other side is x, 2x, 9. So the 9 and the 2x changed order. They flipped around. And the last property that I want you to know right now is the associative property. And remember, the associative property, think about who you associate or hang out with. So if you notice, nothing changed order. It goes 6x2, 6x2. But the numbers and the variables changed who they were hanging out with. So first, the 6 and the x were hanging out in this set of parentheses. And then the x decided to go hang out with 2. So the x changed who it is associated with. The order did not change. Now these three are three of the big properties that you have to know. They're not all of them. We will review other properties, but right now these are the three big ones that I want you to know. All right, let's scroll down to rational versus irrational. I know that at this time you do not have a copy of these notes, so I simply ask that you just follow along. If you want to take notes on a separate piece of paper, you can do that as well. If you remember, a rational number is a number that ends or repeats. And we talked about how a rational person makes good decisions. They make sane decisions. They make decisions that make sense. So some of our numbers here that are rational are 6, 7.2, because it ends. It is a decimal, but a decimal that ends. Something like 3.22222, because it repeats, you can guess the next number that's going to come. Or a number even like 5.41414141. You can guess what the next number in the pattern may be. And remember, fractions are rational. Now, an irrational number is a number that does not end or repeat. End or repeat. So one of the most famous irrational numbers is pi. Remember, pi goes on forever and ever and ever, and nobody knows the end of it. Or a number like 2.189765314 dot 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 dot. That number has no pattern to it. You can't guess the next number that's coming. Now, these are the definitions I want you to use. A number that ends or repeats, a number that doesn't end or repeat. Okay? So there are questions using properties, and there are questions for rational and irrational on your problematic. You have to complete up to zero. All right, order of operations. If you notice here, I have a big purple elephant. That's because order of operations is in PEMDAS. Purple elephants marching down a street. Parentheses, exponents, multiply and divide. Remember, we go left to right, and then add or subtract. Left to right. And luckily, we can use our graphing calculators, so we don't really rely too much on order of operations anymore, but they are still something that you need to know. So always remember order of operations when completing problems in math. All right, let's flip to the next page. Polynomials, and I apologize that this is blurry, but remember polynomials are just things that are made up of many terms. So we have one term, two term, three terms. And there's some vocabulary that you have to remember of polynomials. If you remember, the constant is the number that has no variable with it, no letter with it. Our leading coefficients is the number in front only when they are put in order. So sometimes they like to trick you guys and not put the polynomial in order. And what I mean by order is that the exponents go from biggest down to smallest. But when they are in order, like ours are, we have x squared, x, and a constant, then it's the number in the front. And remember, our degree is our biggest exponent. So our biggest exponent is our degree. In our case, this polynomial has a degree of 2. It's the biggest exponent. So then we did some operations with polynomials, right? We learned how to add them, subtract them. We did subtracted from, and we did some multiplying. Now, if you remember, when you add polynomials, you combine like terms. So all that means is here, let me give you an example. If I had x squared plus 5x plus 2 plus 2x squared minus 3x plus 1, I just combine my like terms. So 1x squared plus 2x squared is 3x squared. 5x plus negative 3x is a positive 2x. And 2 plus 1 is 3. So all you do when you add polynomials is you combine your like terms. When we subtract polynomials, we do keep, change, change. Okay? So what that means is, say I want to subtract these two polynomials. 3x squared minus 2x plus 1 minus, let's do 2x squared minus 4x plus 2. When you subtract the polynomials, you keep everything in the first set of parentheses, change the middle sign to a plus, and change all the other signs. So subtract, that becomes an add, and that also becomes a subtract. And now you just combine like terms. 3x squared plus a negative 2x squared is a 1x squared. A negative 2x plus a 4x is a positive 2x. And a 1 plus a negative 2 is a negative 1. So keep, change, and then combine like terms. Becomes an addition problem. Subtracted from, it's the same thing as the subtract rules, except you have to fold polynomials. And we'll do an example of this one together. So flip the polynomials. And multiply, remember we learned the box method. And we'll do an example of that one together too. Now, before we do the examples here, let's go down to these important formulas that you need to know. Perimeter simply means you add all the sides. So if I want you to find the perimeter of a rectangle, you'd add up all the sides. Area of a rectangle and area of a triangle, these would be given to you on a test or quiz and the Regents exam. Area of a rectangle is just length times width. Area of a triangle is just 1/2 base times height. So of a triangle, 1/2, your base is the bottom, and your height is the line that goes up and down. Think about when they measure your height, they measure up and down. All right, let's do a really quick example of the subtract from and the multiply, and then you will be off to try the last 10 problems on your own. All right, multiply. If I ask you to multiply these two polynomials, we know we do the box. And how we set up the box is we draw a square. We put 1 across the top, 1 across the side, and you multiply. 3x times 2x is 6x squared because you add exponents. 2x minus 1 is a negative 2x. 5 times 3x is 15x. And 5 times negative 1 is a negative 5. Now, we combine like terms. So remember, we go across the diagonal because it tells you to add. So 6x squared stays. A 15x plus a negative 2x is a 13x. And then negative 5 stays. So there's our polynomial. All right, and let's do a subtractive from problem. So say they give you something like this. Subtract 3x squared minus 2x plus 1 from 8x squared plus 4x minus 3. Remember, we talked about from looks like front. So this one, from looks like front. So this guy goes in the front. So we write 8x squared plus 4x minus 3 minus 3x squared minus 2x plus 1. That's the only trick with this one. Subtract 3x squared minus 2x plus 1 from 8x squared plus 4x minus 3. And now we do our subtraction. So keep, change every side, and combine your like terms. 8x squared plus a negative 3x squared is 5x squared. 4x plus 2x is 6x. And negative 3 plus a -1 is a -4. There's my polynomial. All right, awesome job, guys. Thanks for watching. Your task now is to do the 10 problematic questions that I posted on Google Classroom. Please, again, submit your work with these so I can see how you did. Please try your best with them. Please know that Mrs. Duffy, Mrs. Sakala, and myself are all here for you guys. So if you're confused and want to video chat or talk via Google Hangout, we can do that too. All right. So I guess my goal here is to maybe try those problems by Thursday. It's Monday now. There's 10 problems for you to do. But we'll check in on Thursday and see how everyone's doing, okay? All right, have a good night and thanks for watching.